Let's look at number 10 on page 340, and we're talking about the Atkins weight loss program. And it says 40 adults use the Atkins weight loss program. After 12 months, their mean weight loss was found to be 2.1 pounds with a standard deviation of 4.8 pounds. Now that's sample data. Construct a 90% confidence interval estimate of the standard deviation of weight loss for all such subjects. Does the confidence interval give us information about the effectiveness of the diet? So let's go to stat, and we want to do variance statistics, one sample with summary. Now this asks for the sample variance, not the sample deviation. So I have to square 4.8 and I get 23.04. And then my sample size is still 40. I want to do a confidence interval, but I want to do it at 90%. And I'm going to do compute. Okay, so here is my data. Now what I'd like to do is I'd like to bring in a equation editor here so we can type this out. So I want to type my equation, and I'm going to do 16 point, let's take it out 3 places, and then I'm going to do is less than, and then I need to get sigma squared. So there's sigma, and then I need to do a superscript. That isn't what I wanted to do. Structures, a script. And so I want to do that squared, and then I want to do another less than, and then my other number will be 34.970. Well, we don't want to know what it is for the variance. We want to know what it is for the standard deviation. So we need to take the square root of all that. So let's insert another equation. And so 16, the square root of 16.466 is 4.05. We want to round it to 1 decimal place. So we're going to type it in here, and we're going to do 4.1, and then is less than. And then I'm just going to do cut and paste here if I can. Oh, it's not going to let me. So then I'm going to go down and find my sigma again. There it is. Whoops, not there. Down here. Okay, and then I'm going to put my sigma in. And I'm going to do structures to get my squared. When you don't have it where you want it, just drag it into the box. Oh, there would be no squared there. So I'll just leave it blank. And I want to do less than again. And the square root of 34.70 is 5.89, which rounds to 5.9. So that's how I would write it for my standard deviation. Now, the second part of the question says that does the confidence interval give us information about the effectiveness of the diet? Well, no, it doesn't. It gives us information about the variance among the amounts of lost weights, but it does not give us information about the effectiveness of the diet. So I hope that helps with finding a confidence interval dealing with a variance or standard deviation. So now let's look at how we're going to do a hypothesis test for standard deviation or variance, and we're going to use the same example that they did in the book video. So I'm going to remind you about the scenario. We have a simple random sample of 13 statistics professors, and that yields a standard deviation of S equals 7.2. A psychologist claims that statistics professors have an IQ score with a standard deviation equal to the I. So the psychologist says that, hey, wait a minute, the general population has IQ scores with a standard deviation of 15. That I don't think statistics professors are any different. So let's test that. So what we're going to do is in StatCrunch, we're going to go Stat, Variance Statistics, one sample with summary. Now the thing you need to be careful of with StatCrunch is we are using variance. So when you're given standard deviation, you have to square it. So remember, the sample standard deviation of the statistics professors was 7.2. We need to square that, and that is 51.84. And then the sample size was 13. We want to test, the claim is that the standard deviation is 15, so the variance would be 15 squared, which would be 225. And we just think that we think the statistics professors are different than that. So we'll use the not equal to, just as they did on the video. So we're going to go compute. Now notice what we get here is we get the exact same chi-square statistic that Dr. Triola did in the video. But here is our p-value, much easier than using table A4, finding the critical values or estimating the p-value. So since our p-value is so small, we can reject the null hypothesis that the variance is equal to 225 or the standard deviation is equal to 15. And our summary can be, this study gives evidence that the standard deviation of the population of statistics professors is different from the standard deviation of the entire population. Now let's look at the last part of this section, is how do we compare the standard deviation or the variance for two samples. So we'll use the same example that Dr. Triola did in the video. We'll look at the standard deviations in weights, and the weights are measured in pounds of regular Coke and regular Pepsi. And so we had 36 from each sample. So let's go to Stat, and I think you can get it now, variance to sample with summary. And again, we want our variance, and we want to take the biggest one is our sample 1. So that's going to be, okay, we don't need the means. Our regular Coke is going to be the biggest one. So we, again, remember that StatCrunch does the variance. So we need to take our sample standard deviation and square it to get the variance, and this is a teeny weeny little number, 0.1234. 0.5732 will go out, 4 significant digits, and the sample size was 36. We'll do, oh man, now look at what they did to us. They're going to sigma 1 over sigma 2. Sample 1's the biggest one, so we're good. Okay, and then for sample 2, the Pepsi, we're going to take 0.005701 squared, and we get 0.000325, and that sample size was 36. So we said that they're the same. If they're the same, this fraction will be 1. If they're not the same, this fraction won't be 1. So this is exactly how we want it. So let's do compute. And here we get an F statistic of 0.173. What did Dr. Triola get? He got 1 point. Okay, I'm off by a factor of 10. So let's go back and let's double check. I don't have enough zeros in that second one. Now let's do it again. Here we go. So now we get the same F statistic that Dr. Triola got, or just about the same. And our p-value is 0.09. 0.09 is not less than 0.05, so we fail to reject our null hypothesis. So we would say something like, this study suggests that there's no difference in the standard deviations of the weights of regular Coke and regular Pepsi. I hope that helps, and I hope I've demonstrated what you do when you get an answer that doesn't make sense to you. Go back and see what you did wrong. Analyze the answer you got with the correct answer if you know it, and then see if you can fix it.